Hey everyone, 大家好. Hey, I learned a little Chinese over there. Hey, there's still a microphone over here. I don't know where this goes. So, this wasn't part of my thing. So what I wanted to talk about was result-oriented programming in Swift. So if you followed me a little bit in my career, you know I do a lot of talks. So previously on adventures in functional programming in Swift, we talked about taking a function like this that was basically directly converted from an Objective-C and turned into Swift. This is kind of just a direct translation. We threw in a new function called bind. We gave it a nice custom functional style operator, and then we turned it into something like this. Now this reads a little easier, and it's extracted a lot of commonalities of some of the common functions, and it made it just really concise. And it was really nice. So what did we learn from this? We learned that we could take this idea from functional programming and pipe functions together. So we could use functions to build other functions that chain functions together. And this is really useful. But now we want to go further. So we've already noticed from the opening talk at the conference and a couple other talks, we've had this result type. Hey, thanks. Excellent. So we've had this result type that has been mentioned throughout the conference. And what is this result type? I know we haven't really explained it, but that's what I'm here to do. Result is actually the optional type with more power. What it's really good at is error handling, and error handling not just for error handling's sake, but error handling and helping to make your code a little easier to read. And it makes your error handling code look exactly like your non-error handling code. It's crazy, right? You don't have to have all these if statements all over your code just to handle errors. So let's look how we would build the result type. And again, you've probably already seen this, but let's just kind of walk through it. Let's start with the optional. So optional has two cases. It's just an enumeration in Swift. And we have something with a value, an associated value, or we have nothing. So what we want is we actually want to associate a value with the nothing side of optional. And since it's not really none anymore, since we gave it an error, we want to actually change that to something like failure. Well, now failure doesn't necessarily match with the sum, right? Something is good, but it's not really an appropriate name for this scenario. So let's go ahead and rename that as well. So now we still have two cases in our enumeration. We have a success with a value, and we have a failure with an error. So now this is no longer an optional. Now this is what we call result. So that's pretty simple. And just to show you in code, we have the optional type with its generic. So you can wrap any type in Objective or in Swift and wrap it with an optional. And you can just make it look like this: result with a success and failure, two cases, and you have an error. Now, you can see a lot of result implementations using a generic error as a parameter. And you can put any error that you want to be much more specific about your error and result type. But for now, for this talk, we're just going to assume that everything's an NS error. It makes the slides a lot cleaner, and it helps you think about what the result actually is, with maybe not focusing about the error so much as having to specify all of the bits about errors. So let's just kind of run with this version of result for this talk. So let's go back to the optional style. All right, so can everybody read this, what this string is? All right, everybody's learning Mandarin? Yeah. So say we have a function like this, and we return an optional string in this case. Now, what actually happens under the covers, this is nice shortcut syntactic sugar. What actually happens is you have this optional wrapper around the string, and under the covers, you actually get your string value wrapped in the optional. So now you have to unwrap it when you use this. So using the result type is very similar. So you would have something like this. You'd have a result with the specified type that you're actually inside the result value, and you have a success case. So you wrap your value, in this case a string, inside that success case. And if you wanted to use the result type, you could simply do something like this. You have the result from the function, and you can do a switch case, and that's pretty simple. But we can do a lot more than this. So let's take a look at the optional type from the Swift standard library. So if you go ahead and look at the optional headers from the Swift library in Xcode, you'll get something that looks like this. And you'll notice something. You've got obviously the none and the sum, and you've got the generic parameters, everything here. But you've also got two functions here. You've got map and flat map. That's really, really useful. So you can map an optional in Swift. So I want to take a second to really just go over quickly the map versus flat map. Map is a very easy concept. I know it's always the first thing that's talked about in all introduction to functional programming talks. It's a one-to-one mapping of an input type to an output type, and we're just saying this, for example, this collection of bananas, and we map it, translate it to a collection of apples. Right? So we just kind of do a one-to-one mapping, very, very easy. Flat map is very, very similar. So we want to do this map transformation of a collection, but in case of where we have a nested multiple structure, or we have a more deeper hierarchy, it'll flatten it by one level. So it's a flattened step after the map step. So it has the opportunity to remove some values that are invalid, or to flatten your arrays in some cases. So it's very similar to map, but still very useful in the concept of functional programming. Which brings me to this idea of functors and monads. And I know you've probably seen this as well. To me, these are terms that the functional purists have invented to make it more scary. But it's really not that scary. So let's go over that really quick, and just to kind of get going, let's start with functors. A functor is a type that wraps another type, T. Functor of T like that, so we can obviously see that with our optional and our result. That has a map function. Now, this is a very simple definition. Again, the functional purists will give you this three-step definition that has to be mathematically correct for everything to be done. But for programming and for our intent, for our purposes, this is how we want to do it. A functor is a type that has a map function. And it looks like this. I'm sure you've seen the map function. Great. Monads, very similar. It's a type that wraps another type, T. So we have monads of T that has a flat map. Great. That's easy. Now you know functors and monads. Functor has map, monads have flat map. That's it. Very, very simple. Let's keep it at that. And it looks like this. So how do we take that and use that in our programming, in our actual code? So again, we have a string, a value of a string, and in this case, we're using optionals. And here's what it would look like, again, using the non-shortcut syntax with the question mark. And if we wanted to use the map, we could just do something like this. And we could also do something like this if we use our binding operator shortcut syntax. So that's kind of nice. And if you wanted to use a map function, so inside the map function, we're actually doing something like this in optionals. So we actually just switch on ourselves. So this is a function inside of that enumeration that we just unwrap it. And we also are doing, so once we unwrap the value, in this case x, we're going to apply the transform that we're given, right? And then we're going to rewrap it and send it back out as a return value. And of course, if we have none, we're going to return nothing, and that's it. But we're always returning the functor monad in this case. We're always returning something. So for the result type, we're going to do something similar with the map function. So we have switch, we have success, and a failure. Now, there are two cases here. In success, we're going to apply the transform and return the value. And if you notice the transform parameter in this case, it takes a t and returns a result of u. Right? So the transform can just be returned directly. The result of the transform directly comes out of this map function. But in the case of the failure step, what we're doing is we're actually just rewrapping that error into a new result and returning that instead. Right? So we're actually doing something. We're always returning a value. We're guaranteed to return a result of something here, but it could be a value, and it could be an error. And you could do this with the flat map version as well, very similar. So it would look like this once we start using it, right? So one of the things that you notice a lot of times when you're using optionals, you'll have people doing if, let to unwrap it explicitly outside of the things, whereas a map type of function will actually encapsulate all of the unwrapping and the switch statements inside of the enumeration and keeping that stuff clean in there. So that's kind of a nice little trick, letting the enumeration have this kind of function on top of it. So now what we can do is we can take our result and map the value. So now what we have is we just have map and value, and we can just operate on it. So we're actually letting the map function unwrap that value for us. But what happens if there's an error? If it's actually got an error instead of a value? Well, it turns out a lot of implementations of the results type actually have a map error function helper that lets you unwrap the error. And a lot of times what will happen is the map will happen, but the map error will never happen, or the other way around. So you'll never get both of these executing in the same sequence, right? It's one or the other. So it's a different way to handle it. Now, this isn't always the right way to handle the result value. This is a really nice, clean way to do it in some cases. So let's talk about examples, right? So it's nothing without actual looking at a real-life example. Let's talk about micro-networking frameworks. Building HTTP stacks seems to be a good thing to try on this, because a lot of times what I want to do when I'm requesting data from the interwebs is I just want to focus on the actual data type that I'm requesting. I don't really want to worry about the plumbing. I don't want to know that it's HTTP. I really don't want to know about all of the details. What I want is an API that says, I want to request data asynchronously from somewhere. Just give it back. Just give me back the actual data type that I'm looking for so I can move on with this operation. So a while ago, you might have seen a blog post by Chris Eidhoff posted talking about micro networking libraries. And in that, he had a nice little function defined like this, where you can have an API request, and you have a bunch of parameters. And the nice thing about this is it has the URL, and it has this idea of a resource, which has a bunch of other things that apply directly to a networking endpoint, to an endpoint on an HTTP server. And it's also got a completion block, and you've also got a failure block here. So you've got a lot of functional stuff here to help you request data asynchronously. So I went ahead and decided to do my own one, and it's been really nice. So I wanted to, and I also wanted to use the result type to handle the return type, the return response from HTTP. Because usually in HTTP, what you want to do is you want to read the value, you want to, let's see, I think I've got it back here. So let me take a step back here. So what we have is a request, and we've got a resource, right? So what does this resource look like? And we've got a resource protocol, and in this protocol, we've got a result type. So this resource has a particular associated value. So say you have a person object. Now, this is a very generic way, so we're going to have this generic type associated with the protocol. And we're also going to have an error type specified. And in addition, we have various other things that we need in order to request this resource off the network. So one of them is the path, the other one is the query method. All of the details that I really do not care about when I'm talking asynchronously from, say, a view controller or something else at a higher level within my app. So I've got a path, a method, the query method, query parameters, and I've also got a parse function. And in this case, this parse function is it has a result in there. So actually, this parse function was written incorrectly on the previous slide. This is the correct version. It's got an alias to another function, and this uses the Swift 3 syntax, where you can actually have generic type aliases. So you can pass the generic parameter to the next type. So this is kind of nice. So I've got a very generic way to specify all of my parsing over HTTP. So getting back to how I generally would ideally handle things when I get a response back from an HTTP response. First of all, maybe I want to validate the response code. Did I get a 401? Did I get a 500 error? Did I get a 201? Or something that I need that I can do, I can handle right away and kind of return the value really fast. And then if that's okay, then I'll probably try to validate or pre-process the data. After that, I'll say, okay, the data's good, it's not corrupt. I'll deserialize it with JSON, and then I'll decode it with my awesome JSON parser, whichever one was off of that list of your choice from yesterday's talk. And then eventually, I'm going to call a completion handler. You remember my API had a completion block, right? So the completion handler is something that we use a lot these days, and in this case, we passed a result to the completion block. So I want to do all of those. And this is what an implementation of that might look like. So in this particular case, I'm actually created a function that returns a function that will process an HTTP result. All right, so it looks a little weird because the curly braces after the return statement are actually defining another function. right? So what we're going to focus on is just the stuff in the middle here. So this is the stuff to focus on. Looks a lot like your standard completion handler to the NSURL session task methods. So all we're going to do, we'll walk through this real quick. And first of all, we want to build this pipeline, and you've probably seen this before. We have these bind operators with the arrow dash syntax, and that helps us build the pipeline. Now, in order to start the pipeline, we have to fill it with the result first. And in this particular implementation of results, we can cast this response optionally as HTTP URL response. And if we fail, we'll give it some kind of failure error type that we already have defined. So if we already fail and it's returning something that is not an HTTP URL response, the rest of the pipeline will not even will fall through, but it will fall through with that initial error, right? So after that, we'll go to the validate response with error. And again, I'm creating a function that will return a function. And in this case, I'm going to pre-populate it with the error that I've gotten at this particular point. So I'm actually only using in that pipeline the second half of that, the HTTP URL response, returning the HTTP URL response in the result type. So again, we're going to go to the next step in the pipeline. Again, another function that returns the function, and it kind of repeats, and it goes again. And in this case, we also have on that resource, we have a parse function, right? And this parse function is defined as taking data and returning the type that I requested in the first place, that I specified in the HTTP resource as the type that I'm actually looking for. But first, I'm just getting basically binary data, something from NS data, or in this case, Swift 3 uses just data as the type. So you can kind of see the pipeline here as well. So we take validate, and we have our custom validate, we have a parse, and then completion. And you can see it goes from URL response to URL response, and then that result is unwrapped and then piped into the next function, which takes a URL response that returns a result. The data goes into the next function, the parse function, that returns the result of the resource type, and that output gets piped as the input for the next function for the completion block, right? So the completion handler. So this is all part of our pipeline, and all this pipeline works because all of the outputs of the previous function can be used as inputs for the next function. That's how you chain functions together. The outputs have to match the inputs. So now when we look at this, we can see that we're really just taking the result, the data, the response, and chaining it through a functional pipeline using the result. Now, what's nice about this is that when you use result here, if you fail at any one of those steps, the result, the error, will propagate through all the way to the completion block. So you're not writing if fail, call, create an NS error, and then call the completion block with a failure type, or with our failure completion block. If success, call it with something else, with a success type. The success and the failure, they look identical. Success, fail code is the same code. It's only one code. So that's what's nice about doing it this way. So as an example, how I've actually implemented this, I've written an API client to a service out there called Gauges. It's an HTTP analytics site you can put on your website, your websites. And this case, we have a site gauge with a site ID, so I'm looking for data. In this case, the gauge in the HTTP resource parameter type, that's the actual object that I want that has the data that I'm looking for. And I'm requesting all of the information for a particular site ID. And the path is this gauge's site ID, so I just create a nice path. And then what I do is I put it into this request function that has been configured to use a particular host, so it will connect the host base URL with this site gauge URL with the parameters, and it'll build the whole request for me based on all the information I already gave it from the previous function. Now, when I call it through this request function here, I can handle it by taking the result from the request asynchronously and then map that result and then unwrap it using my handy-dandy map function. You could also do it like this to handle your errors, or if you really like to do it the old way, just to be much more explicit, you could also handle it with the switch statement. Personally, I prefer using the map syntax just because sometimes I really don't want to handle the errors. Sometimes it actually is okay to let those fall through. Not always. Please handle your errors. So, do I have to re-implement result to get all the awesomeness? No, you don't have to. If you want to reuse results, you can look at a particular implementation here on GitHub. If you want to look at the library that I wrote that actually is implementing this style of coding, you can grab it here. It's on GitHub. It's all open there now. And that is result-oriented programming. Thank you.